Okay, gentlemen, we are going to attempt to do another problem here. This one's number 10 in your book, and it says find the length and width of a rectangle that has a perimeter of 80 and a maximum area. So again, you are always want to focus at the beginning of the problem. What is it that we're trying to find the maximum or minimum of? And in this case, we're looking for a maximum area. So what we need to come up with is an area function for a rectangle. So let's draw a little rectangle here. And we'll call that width and we'll call that length. And if I'm trying to find the area of a rectangle, my area function, and I'm going to use width and length as my inputs, my area function would be width times length. And again, if I'm going to try to find the maximum area, what I would do is I would take a derivative of this function, set the derivative to 0, and solve it. My problem is this function has two inputs again. That is not what I want to take a derivative of. So I'd like to get this function down to one variable, either as a function of width or as a function of length. So here's where all the extra information comes in handy. And it says this particular rectangle has a perimeter of 80. So the perimeter of this rectangle would be all the sides, and that would be two lengths and two widths. And it says the perimeter is actually equal to 80. So I'm going to use this information to get my area function over here down to one input. I'm going to subtract length from both sides. I could have done either one, but we'll start there. I'm going to divide everything by 2. So 2w divided by 2 would be w, and 80 divided by 2 would be 40, and 2l divided by 2 would be l. And I'm going to, now that I know that width is equal to 40 minus l, I'm going to come over here to my function. I'm going to rewrite it, but I'm going to write it as just a function of length, not width and length. I know that width is equal to 40 minus length, and so I'm going to stick that in here. And now I've got an area function that has only one variable in it. I'm liking that. I'm going to rewrite this to make it a little easier to take the derivative of. I'm going to distribute that L across there. Now I'm going to take the derivative of that function, a prime, and that would be 40 minus 2L. And again, if I'm trying to find the maximum or the minimum, what I'm going to do is I'm going to set the derivative to 0, and I'm going to solve. So let's add 2L to both sides. Let's divide both sides by 2. And apparently when my length is 20, I actually have a maximum area. But of course, this problem asked me to find the length and the width. So how am I going to find the width? I'm going to come back over here and I'm going to use this equation to find the width. I know that the width is equal to 40 times the length. And in this case, I knew the length was 20. And so the width apparently comes out to be 20 as well. Gentlemen, I hope this helps. Please let me know what kind of problems you're having. I can help you on specific problems. We'll just have to figure out the best way to make that work. And some of you guys are probably even better at doing all this technology stuff than I am. So you might even be able to help me find better ways to do what we're trying to do here. Thank you for your patience, and